Today's date is 14th of October 2020, and we will discuss today the advanced welding processes, and we will start with electron beam welding. In short, we call it EBW, electron beam welding. So from the name you can understand, we will form a beam of electrons, and the high velocity, high kinetic energy electron particles will strike the workpiece or filler material, and the heat will be produced because the kinetic energy of the electrons will be converted into heat energy, and thus that heat will fuse the material, will melt the material, and upon solidification it will produce a very good weld. This is an advanced type of welding which is produced by the beam of electron. Now I'm trying to give you a very short uh, information, very short and brief information about it. So as you know, the electron beams, when strike with other atomic particles, even in air, then ionization will occur, and as a result the beam will uh, the beam will not be straight, the beam will uh, spread out. So that's why we need vacuum to transfer the electrons to make the electron beam. And electrons are either positive, electrons are no positive, electrons are only negative, which has electrical poles, or they are negative, electrically charged. So that's why they also need electrical or magnetic focusing. Okay, so let us draw a figure first, and then we will discuss the process. I think it will be more helpful. So first there is a emitter which works as a cathode. Okay, I am drawing very slowly so that you can understand. This is called emitter, and the emitter is placed over a grid, or it is also called a bias cup. Okay, so the bias cup will look like this. I am not very good at drawing, but I will let you understand how this works. So now this, here there is an anode, this anode and cathode both forms the electron beam. Just a second, I was going to calculate it. Hello, हाँ बोलो. हाँ 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 हाँ. अच्छा. ओके. 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 ওকে, আমার যে ডিউ ডেট আছে সেটা ডিলে হয়ে যাবে না তো সেজন্য? ওকে, ইনফ্যাক্ট আমি জানিও না আমার ডিউ ডেট কবে, আমি তো নর্মালি ফার্স্ট উইকের মধ্যে দিয়ে দিই. ওকে. 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 ওকে, ঠিক আছে. থ্যাংক ইউ. Okay, sorry about that. So we were discussing the electron beam welding. Here this is called emitter. This works as cathode. This emits electron. Now this is called a grid, or this is also called a bias curve. Okay, Now this is called anode. Now when these cathode and anode are given a very high voltage difference, then the electron beam forms, and that electron beam, this is the electron beam. This is the electron beam. Now this, because it has electrical properties, this also has magnetic properties. So upon producing coils, these are magnetic focusing lenses. These actually are uh, with use of electricity, they produce magnetic field, and thus they help to focus the beam on a particular point. So this is magnetic focusing lens, which is basically not a lens, we know, but this works as a lens. They concentrate the beam. Okay, now
স্যার ওই ডায়মন্ডের মতো জিনিসটা কি একটু বলতে পারবেন?
এটা
কাইট 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 কাইট
এটা
নিচে যেটা, হ্যাঁ
this
স্যার,
is the
ইয়েস
beam
স্যার।
itself, this is the electron beam.
ওকে স্যার।
Now this beam, this was scattering, you see, this was the scattering. Now using the magnetic focusing lens, we are actually concentrating the beam on a straight line. So this is the job of the magnetic focusing lens. This works as a lens, but this is not a lens, this is just a magnetic field producing coils. So this works as a magnetic focusing lens, which helps the scattered beam to be concentrated on a straight line. These beams, different electrons, they were scattering out. Now they are in diverging format, and with help of this magnetic focusing lens, we converge all these electrons which are running out, and as a result we get a concentrating, converging electron beam in a straight line. Now this magnetic focusing lens, here also we use another object which is called magnetic deflection coil. This is called magnetic deflection coil. Okay, this job of this deflection coil is to make, to bend this, to bend this beam. Okay, so this beam was straight, but with help of this magnetic deflection coil, using the magnetic property of the charged electrons, we can move the coil, we can bend the coil along left and right, sideways. Okay, so here on the table, this is the job, and this is the fixed surface over the job has been given. So this is the max deflected work region. This is working region or working region. Okay, and this might be focused from a particular height. So from this height to this height, say. So this is called focusing range. So with help of this magnetic focusing lens, we can change the concentration point up and down. Okay, is the method clear? Now we will discuss into more discussions. Is the working principle clear? Yes, Gautam.
Yes, sir.
Okay. So now we will discuss on a little elaborately. So let me short out or let me summarize what we have discussed till now, that the electron beam welding is a fusion welding in which the coalition and is basically joint is produced by hitting the workpiece due to impingement of concentrated electron beam of high kinetic energy on the workpiece. As the electron beam impinges on the workpiece, the kinetic energy of the electron beam converts into thermal energy, resulting in melting and even evaporation of the work material. Okay, now we go for the principles. In general, the electron beam welding process is carried out in vacuum. Okay, otherwise it will strike the air particles or any other flying particles, and the beam will scatter. Beam will not be focused, beam will not be converging and not strong. So that's why this is to be performed in a particular vacuum. Okay, in this process the electrons are emitted from the heated filament called cathode, that is called the emitter. Okay, the heating is done by a different uh, electric source. These electrons are accelerated. The electrons are accelerated
Sir,
with.
can you please move the copy little bit upwards? I can't see what is it working. Okay, sir. Thank you, sir.
Okay, so these grid and anode having a very high potential difference. Okay, that is about 30 kilovolt to 175 kilovolt. So accelerating voltage, the electrons are accelerated by applying high potential difference. How much high? About 30 kilovolt to 175 kilovolt between cathode and anode. Okay, now the higher the potential difference, the higher would be the acceleration of the electrons. So the beam will be much powerful depending on this potential difference. So as you can see, 30 kilovolt to 175 kilovolt, which is a very high. Now the electrons get the speed in range of 50,000 to 2 lakhs kilometer per second. Just imagine, electron speed, because of this high potential difference, reaches 50,000 kilometer per second to 2 lakh kilometer per second. The beam is focused by
Sir, 50,000 to 2 lakh, right, sir?
2 lakh. Yes, yes.
Okay, sir. Thank you.
The beam is focused by means of electromagnetic lenses, where the magnetic field is produced by using electricity. Now the molten metal, when the electron impinges on the metal, it melts and the molten metal fills into the gap between the parts to be joined. Now this in this EBW setup, we require electron gun, sorry, equipments. Actually these are major equipments. Equipments are electron gun, power supply, vacuum chamber, with vacuum pump, and work handling devices to produce the welding velocity to uh, move upward or downward the job that a table is required. Now what we have drawn here is basically inside the electron gun. An electron gun generates, accelerates, and aligns the electron beam in required direction and spots onto workpiece. Now the work accelerated gun accelerates the electron by providing the potential difference between the workpiece and the cathode. In self-accelerated gun, the electrons are accelerated by applying potential difference between the cathode and the anode. The anode and cathode are enclosed within the gun itself. The control of electron density is better in this type of electron gun. A schematic of the electron gun is given already in this diagram. So this is basically self-accelerated gun where the high potential voltage is generated between the emitter or cathode and this anode. Okay, so through this anode there is a hole, circular hole, and through this circular hole these electron are comes out with very high velocity. With help of this magnetic focusing lens we concentrate them, and with magnetic deflection coil we can deflect the beam within some region. So the function of the emitter, this is also called filament. Emitter is also called filament. Okay, the emitter generates electron on direct or indirect heating. This heating is again done by electricity. This anode, this is the anode, is a positively charged element near cathode, across which the high voltage is applied to accelerate the electrons. The potential difference for high voltage equipments ranges from 70 to 150 kilovolt. So voltages, we call it high voltage when we use 70 kilovolt to 150 kilovolt, and low voltage equipments which are handling 30 kilovolt to 70 kilovolt. Sorry, this is a medium voltage. Low voltage, low voltage is 15 kilovolt to 30 kilovolt. Okay. Now this workpiece handling device, these are basically a table on which the job or workpiece is placed, and this is inside a vacuum chamber, and this table is movable. This can move in vertical direction as well as in horizontal direction also, and this controls the welding speed, because here the welding gun in most cases does not move, the table is moved, and the movement of this workpiece are easily adaptable to computer numerical control. This is not manually controlled. So let us discuss its advantages. Advantages are high penetration to width can be obtained, because of the beam the material does not uh, get involved with the I mean the spot. The heating is happens only on the spot, it does not affect the materials in the side. Number two, second advantage, high welding speed. is obtained. Number 3, material of high melting point can be welded. Superior weld quality due to vacuum, because there is no chance of oxidation. Number 5, high precision is obtained. Number 6, the material at the side does not get affected. So basically the term is called distortion. So distortion is very less. The heat affected zone is also very less. We have discussed up to number 6. Then the next one will be number 7. Dissimilar materials can be welded. Low operating cost. Cleaning cost is very less because there is no need of cleaning. Just you call it negligible. Number 10, reactive materials like beryllium, titanium can be welded. Number 11, material of very high melting point like columbium, tungsten, etc. can be welded. Number 12, inaccessible joints can be made. Very small to large thickness can be joined. So there is lot of advantages. Now there is disadvantages too, and the most important disadvantage is very high equipment cost, which is very costly investment is required. Second, high vacuum is required. How much vacuum? The pressure ranges is 100 kPa for open atmosphere. Now for partial vacuum, 0.13 to 13 Pascal, and for hard vacuum 0.13 to 133 millipascal vacuum is required. The extent of the vacuum increases, the scattering of the electrons in beam increases. So it causes the increase in penetration.
স্যার একবার একটু খাতাটা একটু উপর দিয়ে করতে পারেন, পার্শিয়াল ভ্যাকুয়াম নিচটা। থ্যাংক ইউ।
Okay. Applications. Okay, we are discussing disadvantages. So there are few more disadvantages. Let us complete it. High safety measures are required for large jobs are difficult to hold, thus difficult to weld, and very skilled manpower is required. So the applications are, as we have said in advantages, like reactive materials, columbium, tungsten, ceramic, this can be joined. Reactive materials are joined, and very important use of this EBW in missiles. In missiles, the reactive materials sometimes are to be joined. In missiles, this EBW is used. Number two, in space shuttle applications, these reactive materials are used, like zirconium, these are all reactive materials, zirconium, beryllium, and these are required for space shuttles. Titanium, etc. Number three, like high high precision welding for electronic components, nuclear fuel elements, special alloy jet engine components, pressure vessels for rocket plants, and dissimilar materials like invar to steel are joint. Okay.
স্যার থার্ড পয়েন্টটা কি লিখেছেন বলবেন
থার্ড
একটু?
পয়েন্টে লিখেছি, হ্যাঁ, ইলেকট্রনিক কম্পোনেন্টস, nuclear fuel elements, special alloy jet engine components, pressure vessel for rocket plants,
ইয়েস স্যার, ইয়েস স্যার।
and last one is the dissimilar materials like invert to steel. This type of joining happens. Okay, any questions on EBW? No questions. Okay, so let us advance to our next topic, which is plasma arc welding. In short, it is called PAW. Here, the process is quite similar. The workpiece is cleaned, edges are prepared, an arc is established between a non-consumable tungsten electrode and workpiece, either between a non-consumable electrode and constricted nozzle. Here, uh, two types of gases are required, one for plasma, one for preparing plasma, and second one is for shielding. So two different gases are required here. So um, there is a plasma torch required. We will discuss one by one. So let us first understand what is the plasma. Plasma is a state of few gases like CO2s are very common plasma arc welding gas, uh, which is very popular, carbon dioxide. So this CO2 has the capability to become ionized upon a very high potential and very high current. So uh, I mean, not so very, not so much high voltage is required, not so much potential is required, but very high current is required. So what is it? It is a fusion welding process where the joint is produced by hitting the work with a constricted arc established between a electrode and workpiece, or the arc is established between a electrode and and another nozzle, constricted nozzle. So what happens? There are two electrodes, and between these two electrodes, the CO2 gas is placed, and a very high current is passed. So the open circuit voltage is about 60 to 80 volt, and the current is 50 to 300 ampere. 50 to 300 ampere. So when this much high current is passed between the CO2 gas, the gas gets ionized and converts into the stage of plasma state. So when it becomes plasma state, it becomes very, it produces very high temperature, and sometimes this arc is produced between the electrode, non-consumable tungsten electrode, and the job itself, which is called a transferred arc. Here the workpiece is a part of the circuit, and in some other cases we use a constricted nozzle as uh, as a anode. So from cathode the arc is formed, electrons transfer occurs, and through this uh, constricted nozzle the arc comes out, and the plasma gases also comes out. So a plasma flame will produce, and in that case the arc is called non-transferred arc, and the method is called non-transferred plasma, where the workpiece is not a uh, directly involved in the circuit. Workpiece is not involved in the circuit. So what I am saying, when this is the job and this is the electrode and the plasma occurs like this in a bell shape, this is called, this is minus, this is plus, this is the job and this is the electrode. Okay, so this is called plasma. So this is a transferred plasma or transferred arc, where the job is a part of the circuit. But when this is your electrode and this is your nozzle, this is your constricted nozzle. So when this happens and here is the job, so the plasma flame will comes out. So the job is not a part of circuit, then it is called non-transferred arc. So here the joint is produced, the heat is produced by the arc. Basically the plasma arc welding is a type of arc welding, but here the gas in this region, in this region or in this region is filled with CO2, and the CO2 reaches the plasma state, and thus upon ionization increases the heat, and that's why it is called plasma arc welding. Now there are two type of arc is produced. One is non-transferred arc, second one is transferred arc. In transferred arc, the electrons getting transferred directly to the workpiece. Workpiece is a part of the circuit, that's why it is transferred. In non-transferred, the job is not part of the circuit. Okay, is these two terms are clear? Transferred and non-transferred.
Yes, sir.
Okay. So in this PAW process, the workpiece first cleaned, then edges are prepared, then the arc is established between a non-consumable electrode and workpiece, or between a non-consumable electrode and constricted nozzle. Okay, inert gas is passed through the inner orifice surrounding the tungsten electrode, and subsequently the gas is ionized and conducts electricity. So if you transfer inert gas just beside the tungsten electrode or non-consumable electrode, the gas flows through this nozzle or flows through this uh, region between these two cathode and anode, the gas gets ionized, and this uh, total weld pool along with the plasma is shielded by another inert gas. So this is one container, and there is other container outside, and through this shielding gas, sorry, SHIELDING. So the shielding gases are transferred and they produces a shield. This is gaseous shield, and thus it it saves the weld pool. So there are two different inert gases are to be given.
Sir, above non-transferred arc, what is written? Some shield?
এখানে
Uh-huh.
gaseous shield.
Okay, thank you, sir.
Okay. Now filler material might be applied separately or sometimes may not be applied. So the workpieces are cleaned, edges prepared, arc is established, then inert gas is passed through the inner orifice surrounding the tungsten electrode, and the gas gets ionized, conducts electricity. This state of supply and gas flow are turned off once the welding is done, and the workpiece is suitably cleaned after cooling. Okay, power source is used, a conventional DC current power supply with drooping VI characteristics. Conventional DC current power supply with drooping VI characteristics is required. Okay, voltage. Now here both rectifier and generator power source may be used, but rectifier type is preferred.